So this exercise focuses on just purely multiplying matrices. Now, the rules for multiplying matrices, they're not as obvious as adding or subtracting matrices. So also be very, very careful not to confuse this method with the scalar multiplication, which we used in exercise 7.2. So it's different. So remember, anything highlighted, that's the important stuff. That's the stuff that I would be putting in a summary book. So we may only multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. Okay, so what we have here, so if we have a look at this matrix A, it's of order 3 by 2. B is of order 2 by 1. So if you've forgotten what order is, remember that's the number of rows multiplied by the number of columns. So C, we've got 1 row and we've got 3 columns. So it's a 1 by 3 matrix. So again, our rule says that we can only multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. So let's have a look at matrices we can multiply. Oops. So if we have a look here for A, oops, sorry, that's not working. So we can multiply A times B. We can multiply A times B because A has 2 columns and B has 2 rows. We can also multiply C by A because C, being the first matrix, oops, not that one, C has 3 columns and A has 3 rows. So those two can be multiplied. We can also multiply B times C. We can multiply B times C because A has 1 column and C has 1 row. So they can be multiplied. But what we can't multiply B times A or A times C or C times B. Now that's kind of counterintuitive because if we were to multiply, say, the numbers 3 times 2, that would be 6. And we can also multiply 2 times 3, and that would be 6. With matrices, the order of multiplication is very, very important. If we consider multiplying B times A. So this time, B is the first matrix, and the number of columns in B is 1. And if we multiply that by A, the number of rows in A is 3. So 1 does not equal 3. Therefore, we cannot multiply B by A, even though it was just fine to multiply A by B. So So let's make a note there. Order of multiplication is very important. So another way we can think about this rule is to consider the first matrix as being of order Mn and the second matrix to be of order PQ. We can multiply the matrix if and only if n, so the number of columns in A, is equal to P, the number of columns in B. It also happens that if we multiply these two matrices, the resultant matrix will be of order M times Q. So if n is equal to P, we can multiply them, and the matrix that we end up with is of order M times Q. So we'll do an example and then it'll start to make sense. So for imagination purposes, we'll say that we have some matrix A. It's got 6 elements. Doesn't matter what they are for the moment. I've got some matrix B with 2 elements. If we want to multiply A times B, we can do that because the number of columns in A is 2 and the number of rows in B is 2. So here we have a 3 by 2, and here we have a 2 by 1. So if you want to multiply A by B, then we end up with a matrix. So I've got a 3 times 2 and a 2 by 1. Our resultant matrix is of order 3 by 1. And here's our 3 by 1 matrix. So obviously I've just used an imaginary matrix there, but now we're going to work out exactly how you do that multiplication. So it is tricky. Well, it's not that tricky. It's hard to get your head around. So spend a few minutes, maybe go over this twice. Once you've got your head around it, it'll be easy from then on in. So what we actually do is we take the first row from matrix A and the first column of matrix B. So for these examples that I've got there, so we take that first row of the first matrix and we take the first column of the second matrix. The second step, so we find the sum of the products of their corresponding components. Once we've done that, then we're going to go to step 3, which is to take again the first column in matrix A, and this time we'll multiply it by the first row of matrix A, and we'll multiply it by the second column of matrix B. And we find the sum of the products of each of those elements. what you're going to do then is repeat the process until each row in A has been multiplied by each column in B. So if we think about it, we're going to take this row and we're going to multiply it by this column. And then we're going to take the first row again and multiply it by the second column. Then we're going to take the second row and multiply it by the first column. Whoops. And then we're going to take the second row and multiply it by the second column. So there are 4 different things that are going to happen there, so it makes sense that we're going to get a matrix with 4 different elements in it. So this is a 2 by 3 matrix, and this is a 3 by 2 matrix. So we can multiply them because we've got our n equaling our p here. The resultant matrix should be a 2 by 2. And here we've got our 2 by 2 matrix. So theoretically, what should happen is we take that first row and we multiply it by the second column. First row by the first column. So first row by the first column. And we take each element. So we take A11 and we multiply it by B11. Then we add that to A12 times B21. And then we add that to A13 times B31. And we get the result C11. Then to get C12, we take the first row and multiply it by the second column. And again, we go through that process of multiplying corresponding elements and adding them together. So we do similarly for the second row and the first column, and the second row and the second column, and we get all 4 results. So I'll do a real example and then it'll really start to make sense. Okay, so this is going to be slightly different because this time I'm going to multiply A times B. Now here, in this theoretical example, I was multiplying a 2 by 3 by a 3 by 2, and I got a 2 by 2 matrix. But here, we're multiplying a 3 by 2 times a 2 by 3. If we do A times B, we can do that because we've got our n equaling our P. But the resultant matrix is going to be a 3 by 3. So what we're looking for is some A times B, which will give us some matrix 3 by 3. So it'll be C11, C12, C13, C21, C22, C23, C31, C32, C33. So to find C11, we are going to multiply the first row in A by the first column in B. We're going to multiply each element and then add them together, each corresponding element, and add them together. So what we're going to have is 5 times 2, and then we're going to add that to 2 times -1. So what we should get is 10 minus 2. Be very careful with your negatives when you do this. Lots of room for error, so be really, really careful. Second, we're going to find C1, 2. So also take note of which rows and columns go where in our resultant matrix. So C1, 1 is the one we do first, C1, 2 we'll do second, and then C1, 3. So they're all, if you look at it, row 1 multiplied by column 1. Row 1 multiplied by column 2. Row 1 multiplied by column 3. So I'm up to C1, 2, which means I'm rowing row 1 multiplied by column 2. Oops. So we're going 5 by 1 this time, and then 2 plus 2 by 0. So that's going to be 5 plus 2, 5 plus 2, 5 plus 0, which gives us 5. Now we're C1, 3. So we're still multiplying using row 1, but we're going to now multiply that by column 3. So this time we've got 5 by 3 plus 2 by 2, which gives us 15 plus 4, which equals 19. Next one, we're going to C2, 1. So we're moving down now. Oops, rid of that. So we're now multiplying row 2 by column 1, row 2, row 2 by column 1. We've got -1 times 2 plus 3 times -1. -2 plus -3, which gives us -5. Again, be careful of those negatives. So you can carry on that pattern. So you can find C2, 2, C2, 3, C3, 1, C3, 2, and finally C3, 3. So for this first one, C2, 2, you're multiplying row 2 by column 2. Then you'll do row 2 by column 3, row 3 by column 1, row 3 by column 2, and row 3 by column 3. And you should get, if you do all of those perfectly, you should get -1, 3, 6, 2, and 2. It's tedious. So in other words, if we multiply A times B, we get this particular resultant matrix. So putting each of those values into the matrix, C1, 1 is 8, C1, 2 is 5, we've got 19, -5, -1, 3, 6, 2, and 2, and that would be our final answer. So just make note that if you have two matrices, A and B, AB does not necessarily equal B times A. So if I was to do this matrix B times A, and we'll do it on the calculator to prove that they're not the same. But we should see that if I was to multiply B by A, then what we'd have is a 2 by 3 multiplying a 3 by 2. So our resultant matrix will be a 2 by 2, which is quite a different matrix to the matrix we got, because we got a matrix of 3 by 3. So the order of multiplication is very, very important. Okay, so we'll do this question again on the CAS so you can see how that's done. So we want it in calculator mode. We will enter our two matrices. So remember, you click on this button here. We click this symbol, and our first matrix, this first matrix was a 3 by 2. So using the tab to go down, we get a 3 by 2. It's great. We enter our values. We want 5, 2, -1, 3, 2, and -2. We're going to store that matrices, so we press Control, and then we have this stow button, which is the same as the variable button. Get that little arrow. We will call it matrix A. Press Enter. There it is. We want another matrix, so we press this function button. We want this particular value. Our next matrix is a 2 by 3. Great. We enter our values. 2, 1, 3, -1, 0, 2. We're going to store that. Control store. We're going to call that B. If we want to multiply those matrices, we just press A times B, press Enter, and hopefully we've got the same matrices that we started with initially, and we do. So 8, 5, 19, -5, -1, 3, 6, 2, 2, and that's what we got over here. 8, 5, 19, -5, -1, 3, 6, 2, 2. Great. So we'll try it again, multiplying them. Instead of multiplying B times A, we'll multiply A times B. So if we multiplied B times A, oops, get my cursor out of the way, B times A, we get quite a different matrix. Oh, I did try A plus B, and of course that doesn't work, because if you remember when we add and subtract matrices, they have to be of the same order. So it's no good, because we had a 3 by 2 and a 2 by 3 matrix, so they cannot be added. But we can either multiply them as A by B and get a 3 by 3 matrix, or we can multiply it B by A and get a 2 by 2 matrix. So now for the fun bit, I would like you to try exercise 7.3. So really like you to try questions 1 to 5 and 6. And if you feel like a challenge, try a few harder ones, which is 7, 8, 9, and 10. Don't be afraid to use a solution manual to help, or snap me, of course, if you get stuck, preferably after Christmas. I'll show you what they look like. So question 7 is only really tricky because it involves the identity matrix and the zero matrix, and you just asked to show things like that if you multiply A times the identity matrix, that in fact the order doesn't matter here, and if you multiply the identity matrix times A, both ways you'll just get back to your original matrix. Question 9 and 10 involve a little bit of algebra. Again, it's just sort of verifying a few algebraic laws that you know exist in normal mathematics. So for instance, something like the distributive law, where if you had a bracket, you'd usually expand that bracket, and you'd know that that would be the same as saying that A times B plus A times C. And you just want to show that if you did that for matrices, so if you added matrix A and C together and then multiply it by A, that you get exactly the same thing as if you multiply A times B and add that to A times C. So you have to verify it by actually doing the calculations. So follow the solutions manual. If you get stuck with them, ask me. They are challenging. Yeah, don't be alarmed if you find yourself in a bit of a pickle. Good luck.